welcome to today's webinar about speeding up photogrammetric production during peak season. So my name is Simon Grandin and I'm the photogrammetry workflow specialist here at SimActive. So today the topic of the webinar will be basically we'll show you some challenge that you can get during production season and how you can manage them. We'll also do a review of correlator 3D processing option on the different methods, so the GUI, the automated workflow, and even the scripting options. We'll also show you how you can use scripts and batch process some of your project. We'll discuss about how you can split a correlator 3D project based on the project type. And as well, we'll finish with some real-world scenarios and see how you can manage them and what it takes to get them successfully done. Finally, at the end, we'll answer some of the questions that we have. So feel free to write us questions during this presentation in the Q&A box, and we'll, as much as possible, try to answer them at the end of the presentation. So let's talk about the production challenge that you can have during peak season. So sometimes, well, summer for aerial imagery, it can be a lot of flying season. So means a lot of data to process. The numbers of project can pile up really quickly. The deadlines are sometimes short, and also the size of the project can be variable depending on the business that you have. So those are all things, all challenges that you can have during your peak season, and they can all affect the way that you're going to process some of the photogrammetric project. Let's say the size of the project will have a big influence on the parameters that you will use, but also there's different things to consider before you're going to start the whole processing or the whole your whole production. A few things that you can take a look at before starting your whole processing machine is basically the hardware requirements. So what's the hardware component that you have for your photogrammetric project? So are your drivers of your graphic cards are up to date? Do you have enough storage space for all your data? How many? Again, the numbers of licensing is gonna have an impact on your processing resources. Sometimes if you have a lot of project, well, maybe you can have more than one license to split up a different part of the project on different machines. Also, if your processing, if your project are similar from project to project, well, you can automate some of the part of the project, which we'll talk a bit about in this presentation. Also, there's the type of workflow that need to be addressed before starting the project. So let's say if you're flying LiDAR, well, you need to pre-process the LiDAR data and make sure that your intensity map is properly built. You have your DEM if you want to auto-rectify it on it. Then you can collect your ground control points. So those are all elements that can affect or that can change the way you're processing your data within correlator 3D. And lastly, I think the accuracy requirements that you have for your project is basically a big part of a big challenge. It's not all of the project that will be processed the same way, and the accuracy is going to depend on which parameters you can tweak depending on what you need at the end. Let's say if you only need an ortho mosaic, well, you won't generate the DEM at full resolution. You may want to shortcut on this. So that's other things to consider before starting up your whole production. So now let's review basically the processing option of correlator 3D. So as I said before, there's basically three main options for processing data in correlator 3D. The first one, which is the most used one from all our users, is basically the graphical user interface. So the GUI interface is an interactive processing where you can see the processing going on your screen, and you can quickly visualize the data as it gets processed. That's one way to do some quality control. It can be also useful if you want to clean up some data sets before starting up your whole project. So let's say your drone was taking images from the takeoff up to the takedown. Well, sometimes you may want to remove some images that are not related to the photogrammetric process. So you can use the graphical user interface and our cleaning flight line tools to remove some images that can sometimes blurry out the outputs or that are not related to the whole process. Again, the GUI interface can be used to run script. So let's say your project was already created, you've generated a script with the automated workflow. You can run the script directly with the graphical user interface. You can also call the automated workflow from the graphical user interface, which I will talk a bit about later in this presentation. And so basically the graphical user interface is the best tools to learn about the software and use the software, I think personally. So if I show you how it looks, basically we have here the graphical user interface of Correlator 3D. So basically the software is built as a modular architecture where we have the module divided into 3 big modules. We have the AT modules, the DEM generation modules, and then we have the ortho mosaic modules. We also have a few add-ons such as the 3D model generation, the contour lines, the volumetric calculation. So those are all other modules that you can find from the graphical user interface. All the modules that you see in the GUI interface can also all be scripted out with our own scripting tools that I will talk a bit later in this presentation. Also from the GUI, as I said, you can call up the automated workflow, which is the second way you can process data in Correlator 3D. So the automated workflow basically is what we call a one-button click solution, where it can be useful if you want to run a quick overview of the project, or let's say you can run if you want to automate a lot of the steps. You can use the automated workflow to build some scripts directly from the GUI interface. It can help you to familiarize with our scripting tools and your own data. There's different profile that can be associated with the automated workflow. So depending on your needs, if you need a true ortho, a classic photogrammetric project, if you want to have a quick, fast project, just an overview of the project. Well, we have different profile that can be selected from the automated workflow, depending on your project needs. You can also customize your own options with the automated workflow. So based on the setting that you want, well, you can set the resolution of your DSM or your DTM. You can set the ortho resolution. Also in the AT part, you can set the type of bundle adjustment process you want. Once the automated workflow is launched, well, basically all the results are displayed directly on your screen after the processing, so you don't have to reopen the project. It can be useful to quickly visualize the outputs. And I think the most useful thing with the automated workflow is basically its capacity to generate some script if you want to start familiarize yourself with the scripting tools from Correlator 3D. So let's say if we're into the automated workflow, well, you can set your own profile here, so based on your needs. And then you can select the scripting option here. So it won't process the data, but as soon as you click on process, it will generate you a script like this, and you can then use the script to start scripting out, and then sometimes just tweak out a bit of the parameters. So this brings me to the one way of using the automated workflow is sometimes In the photogrammetric project, the most critical part is the arrow triangulation. So the AT part is where you're going to refine all the bundle solution, and basically it's there that you validate the overall accuracy of your solution. So what sometimes we can suggest, if you want to quickly get data going into Correlator 3D, you can manually run your AT, so doing the type 1 extraction, the bundle adjustment. Then you can review your AT results, so you're sure that the quality reports and the solution meets your project needs. And then you can use the automated workflow to check off the AT module, and then just run the rest of the project. So let's say you're in the end of the afternoon and you got a quick project to process. You run your AT, you set your parameters. Before leaving, you just make sure that the AT fits your project needs, and then before leaving, well, you start your automated workflow, and you should get the rest of your processing the next morning when you come back to work. That's one way of using also the automated workflow. Finally, the last steps of processing data in Correlator 3D, which is a bit more advanced, is the command prompt and the scripting tools. So basically, everything that you see in the GUI interface, or almost everything that you see in the interface, can be run within the command prompt. So basically, we have an input, you can select a process, and then you have an output at the end. The syntax of those scripts are pretty much simple. It's our own syntax that can be found in the user manual. I will talk a bit about how you can build some script later on in the process. So all the parameters can be used in the script, and also the script can be run, let's say, from the GUI interface, or they can be run as a command prompt, or they can also be called by another scripting languages such as Python. So let's say you have a few of processing to do upstream of your Correlator 3D processing option. Well, you can build a script that once your upstream processing is done, you can then call your script of Correlator 3D and then run directly the program without having to launch the graphical user interface. So if you want to run the script from the GUI interface, you can either go into File and then run Script, and then you'll be able to select the location of your script and then directly run from the GUI. However, if you want to run into Correlator 3D, well, you can call in the command prompt Correlator 3D with the path of your script and then run the process without having to launch the graphical user interface. So now, talking about how you can use script and batch process some of the modules. So how the script is built, basically. So from a script, we have the name of the module that is used, and then we have all of those parameters. So the parameters basically are going to be usually the input folder from this modules. Here in the AT, well, we have, let's say, the camera calibration, the EOS adjustment, the extraction type. So those are all features that you'll find in the graphical user interface, but they can all be changed within the script. If you want to start building up a script, well, we have all the modules already pre-scripted. So if you go into the tools, the sample file menu here, well, we have an example here of all the scripts, of all the tools that can be scripted out. So as we can see here for the AT part, well, we have a lot of adjustment possible based on the input data that you have. So you can really go deep with the scripting tools with Correlator 3D. So it can be from the AT up to the mosaic export So all the modules can be used for scripting parts. You can also send your logs to other files if you want to have, let's say, if you want to see the timings of your processing. You can create a custom logs file that can gives you some tips on how times it took for processing your project. Having said that, if you want to launch a script, there's one big if. Well, usually the project need to be already created. So we start the script with our own IO file, which is created at the project creation. So usually, if you want to run a script, you have to create your own project from the GUI interface and then start your scripting. However, we also have a tool that is called ConvertEO that can be used to create automatically your project. So the input file that we need for the processing. So as it's called, the ConvertEO is basically a tool that will create the input IO file that is required for your project. So if you want to create this IO files, you need a few input prior to call this function. You basically need the input camera file. So it's going to be a cam file which contains the minimum pixel size, the image dimension, and the focal length. All the distortion can be calculated during the bundle process, but we at least need the focal length, pixel size, and the image dimension. We also need a TXT file that will contain the input coordinates of each images. So it's an EO file. The minimum we need is basically the X, Y, and Z data. The IMU data is optional, but depending on the accuracy that you want, you may want to use IMU data that is provided with your imagery. We need also the projection system of your project and the image folder where all your image are located to. So basically, if you want to use this ConvertEO function in your script, it needs to be run prior to run your script. And basically, this will create the IO file, and then the script will use this EO file to run all of the rest of the processing. If you want to see a bit more about the ConvertEO, well, this command is located into the installation folder of the software, and you can directly call the ConvertEO from the command prompt. So now let's see if you have, let's say, a multiple project to process, but you don't want to sit in front of the computer and then run all your project. Where you can use let's say, some more advanced scripting, scripting languages to automate the reading of multiple scripts as a batch. Typically, you can use the DOS command or bat files to run such script, or you can, if you're a bit more advanced, you can use a script like Python to call directly Correlator 3D and multiple script. So let's say here I'm going to show you the example that I have. So we have here we have an example of three projects. So I have, let's say, project 1, project 2, and project 3. Those each of those projects contains a folder with the images, the script of this project, the EO text file, and the camera file. So those are the minimum requirements I need for creating my project and then run the script of the project. So I have 3 different projects, and what I would like to do is basically run a script that will run the 3 of those projects once after the other one. So once the project 1 is done, well, it's going to run to the project 2 and then run to the project 3. And after each project is done, it's going to take the output of the project and copy it to a deliverable folder, that I have. So let's say here I would like to use a for loop to loop into all the directories that I have here in my folder. So I have two scripts. So I have two scripts here that I can show you quickly. So I have the run script, which contains my ConvertEO and then my script, and then the copy of my delivery into the deliverable folder. And I also have the go script, which basically gonna call the run script for each project. So it means that here, for every directory in the path that I have specified here, which start with 0, because I don't want to loop into the deliverable folders, do call the script run, which means for every folder, I'm gonna call the script run, which this scripts create the project, run the project, and then copy the deliverables of this project into another folder. So all I would have to do is basically run the go script, which will call the run, and then it will process all of the project. So what it will do is basically it will run. It will go into the folder 1. It's gonna run the ConvertEO, which will create my project with the cam file, the txt file, then use the script number 1, do the whole processing, and then copy the deliverables to the deliverable folder. So that's one way to use such loop. So you can see that quickly you can run multiple projects. If you're not sure how to use the ConvertEO file, you can always create all your project prior to run your script, and then just call your script one after the other one. So now that we've seen a bit how you can manage multiple script at the same times, let's see how you can split a correlator 3D project based on the project type that you have. Though there's different ways you can process a project. The first one, which is not the most common one, but it's the most it can be an important one, is you can split the project before the AT. So let's say you have a lot of images and you don't want to run the whole process into one project because you want to get let's say your project out quickly, or part of your project quickly. You can have multiple blocks of images, but you got to make sure that you're going to have common features, here in this case common ground control points, between those two blocks. This way you'll make sure that you'll have no shift or no breaks between both blocks of the project. So that's one way you can split the project. Also, if you want, sometimes you can run for the first part and then take the output of the first part and then use them as input ground sources for the second project, and so on. So you can have multiple blocks like this as well. The other way to run a project, which is personally one of the one I suggest the most, is if you have access to sometimes multiple licenses, well, you can run the AT on computer. This means that the type points, the ground control points, and all the image adjustment will be done on all the images. This way, you should ensure that you have a nice stable block of images that is built, and then you can export the EO and the cam output of your AT onto a new machine, and then run the DSM and the ortho on the second machine for half of the project, and you also run the other half on the other machine. So that's one way you can run the DSM and the ortho on two separate projects. As if you're using the EO and the CAM file exported from your AT, it's basically if you're exporting the AT solution of your project. Then once it is done, you bring back all the ortho together, and then you can generate a seamless mosaic with all your ortho. So that's one way to run project. And if you want to run, let's say you only have one computer, but you're running an AT on the big project, but you wanna have subsample of your project delivery quickly, you can disable some images of your project. So let's say if I'm looking at the GUI interface here, we can have here in this case only run a few flight lines. So if you want, you can disable some of the flight lines. So if I want to only deliver, let's say, the first two flight lines of my project, I can select flight line 2, 0, and 1, 0, 1, and 2, sorry, and then I can use the disable flight line here, and by disabling them, it won't use them in the processing, but they will still be kept in the project. So it will only run the DSM, the ortho on those specific flight lines, so you can manage smaller section of your project using a workflow like this. The same workflow can be used for the ortho. So let's say you have a large amount of ortho, but you only want to generate a mosaic on the smaller section in your ortho section from your project tree. Here you can disable subsection or some ortho here. It can also be done by clicking them on the GUI and then just disable them with the shift button. So you can hold the shift button, select multiple images, and then just disable them in the project tree. The last way you can divide a project is, let's say you have access to a floating license where you have two instances on the floating license. Your project is stored on the network or on the server. If you have on the mosaic, you can split the mosaic into multiple blocks. So when you create the mosaic, you can say to the software, well, I want to have two different blocks of mosaic. So when I will be doing the seam line editing, I can have two people at the same time doing editing on different blocks. So that's one way to tackle down seam line editing. And also, I can announce you that in our next version, which is going to be ConvertEO 3D version 9, we will introduce the distributed processing. So from one computer, you will be able to directly launch some of the modules, so type points, DSM generation, and ortho generation. You will be able to run or launch modules that will be used on different computers automatically. So it's going to speed up a lot the processing of your project. So that's going to be probably by the end of the summer, beginning of September, we should have this implemented in our ConvertEO 3D version 9. So now we've seen how you can manage some project. Let's see how you can break down the project, or how it can apply on different project types. So the first project scenario is basically the smaller one. So you have a small single mission. It can be you can use the graphical user interface to quickly run the processing. So depending on the numbers of images, well, it's going to be fairly quick. Let's say you have you have below 1,000 drone images. You can tackle your project within half a day, and then by the end of the day you should be able to deliver the output to your customer. So the processing time, as I said, is fairly quick. The only human interaction that is needed for such project is basically if you need GCPs to be added during the AT part of the project, you can import your GCP, tag them in the images, and then run the rest of the process as an automated workflow. For a smaller project like this, since it's really quick to process, well, the quality control can be done at the end of the project. So since it's fairly quick to process, you can run such project on a smaller laptop with a basic GPU and none of RAM on your computer. Basically, all you need is typically a UAV pilot that will collect the data, surveyor if you want to have GCPs for your project, and probably a GIS technician that can run such project and can be delivered to your customer. The next project, which is a bit more complex, but still we're in the same ball game of the first one, is the multi-mission UAV project. Sometimes those projects can be larger depending on the numbers of mission and the days of flying that you're doing. Let's say if you're flying over a week, well, the interactive project creation can be used, let's say, to have different groups for each mission. So let's say you're processing, you have around, I would say, you have around four flights that was done onto one day of flying or half a day of flying. Well, for each flight, maybe you want to use one different groups, so you give a bit more flexibility to the AT. So at the project creation, you will select 4 groups with 4 cameras, and each flight will be one group. So it's going to give a bit more flexibility to the final project. Again, depending on the numbers of images and the size of those images, it can go for a day or maybe more. The interaction can be necessary if you want to tag some ground control points. Again, here things to consider. As I said, depending on your needs of your project, well, the resolution of your DSM will have an impact. So if at the end you're looking only for an ortho, maybe you wanna raise down a bit the resolution of your DSM, so it can accelerate your processing. Typically, the DSM generation section of a project is up to, I would say, 40 to 45% of the whole project time. So that's that by taking off or by lowering down a bit the resolution, you can narrow down the processing time of your project. If you wanna consider doing some QC on such project, you can use the disable function to only run DSM and ortho part at some group boundary. So you want to make sure that all the groups are properly attached. Such project can be run from the graphical user interface. And again, here, as hardware, a standard PC should be sufficient enough. I would say for most of the project, a good GPU on the CPU, it's going to be usually the clock speed that's going to be the important variable, and having an SSD drive will make a huge impact on the processing speed you're able to get from your project. Having a project of a multi-mission project like this can be run with, let's say, a UAV pilot that will collect the data, again, surveyor with ground control points, and the GIS technician that should be able to process such data. Then the third one, which is it's not the most common one, but it's something that we see we see sometimes. So it's a continuous streams of UAV projects. So it's the same type of project you're processing over and over again, and basically you wanna have like a good workflow, so you don't have a lot of human interaction behind it, except of doing the QA of your project. So if you have continuous project or similar project process one after the other one, well, using the scripting option can be good for such project, as the parameters are similar from project to project. So in your script, you can also include copying the output files to separate folders, so you can directly do your QC once the output are generated. Sometimes some of the people prefer to have virtual machines or cloud instance to run such project, as they don't have to rely on desktop machine. The things to be aware is the upload and download download speed. This will have an effect on your processing stream. To run the software on a cloud instance such as the AWS or Azure instance, we require floating license, but the software can be run as an Azure or AWS instance without any problems. Sometimes the downside of that is, as I said, the upload, download, and even the reading and writing speed that you can get. It's not optimized depending on your data size. It can be useful to also run continuous project on desktop machine. If you want to probably run the software on a cloud instance, just a technician, a programmer that can build you some script, GIS specialist that can take a look at the product that are generated, doing the QC on it. And maybe a system engineer that can build you your own setup on AWS and make sure that you're able to upload and download all your data. Again, the next one, which is another rare one, but we've seen a couple of times. It's a single project with a discontinuous area. So let's say on such projects, well, you can run, depending on how far the different blocks are, you can run either different project for each block. As some of the processes we have are continuous processes, such as at the DSM, so it can be useful to run different project individually. But if it's for the same type of project, you can build script to run, let's say here, different batch of project. The ConvertEO can be used to automatically build those projects. The processing time gonna depend on the numbers of images. the resolution and the accuracy that you need. So again, if the areas are close to each other, you can try to run them as a one project. But if there's really far one from each other, you can run different project for each section. Again, as hardware, a standard desktop PC should be sufficient. Finally, the last type of project, which is a bigger project that requires a bit more of knowledge and preparation, basically is larger format cameras, or even larger UAV datasets, more than 10,000 images. Sometimes the AT can be run into one single batch. You can then mark the ground control points. But for such project, when you have larger data sets, it's usually a good thing to have someone who has a bit more experience in photogrammetry to take a look at the quality report. You don't want, since it may take a lot of time to process, you want to make sure that you do a quality check between each steps. So you don't miss up any details, and your timeline is going as accorded you've planned before. So let's say if you're planning up a big project, you can run the AT on the whole project. Then you can break down the project into smaller sections if you want to have smaller deliverables, so it's going to be easier to manage. You can use the disable flight lines option to have to break down your project into smaller sections. For such projects, also, since the processing time is usually more important than smaller project, well, you want to maximize the processing time. So you're doing your QC during the day, and once you're ready to leave, maximize the overnight processing, since no one is using the computer. Again, on Corelator 3D version 9, this will be greatly improved, as before leaving, you will be able to use different machines to accelerate the overall processing of your project. When you're working with larger data sets, you may want to run a workstation that is a bit more robust. So you want to have a good graphic card. Well, here we have a 1080, but you can go with the RTX series, the 2080. Even the 3000 series, that's other good graphic cards. SSD drives will have a big impact on the processing speed. Again, the storage capacity is also going to be a big impact when you're managing larger data sets. Well, you can store a lot of data, so make sure that you have enough space and enough disk to store all the data. If the size is limited, for instance, you can use the compression for the ortho that will help to reduce the size of your own data without any compromise on the quality of the outputs. So sometimes for such project, it can be good to have a project manager to make sure that the deadlines are okay. Some GIS specialist or technician that can do the let's say if there's some type points to add, if there's some DM editing to do, or some scene line editing to do. Well, you can use such resources to do so, and certified photogrammetrists to make sure that the AT results meets what what the accuracy you need for your for such project. Also, if for any instance you have LiDAR for such project, you can directly import LiDAR in your workflow, and it should reduce the amount of times you have for your project, since you can use the elevation data from the LiDAR to derive the ortho photos and then colorize your LiDAR point cloud. So again, here, just a few quick unique benefits from Correlator 3D. So we have unmatched processing speed. So we rely a lot on the GPU, and we're able to get a pretty good speed on a lot of types of sensor. We have no training is required. Well, we have the automated option, the automated workflow option, which is like a one button click solution. But we also have users, more advanced users that can fully customize their workflow. We can ingest a large amount of images, and the software can be run on a cloud instance, AWS, Azure instance, and can also be scripted out with a command prompt. We have different types of options for licensing. So we have the yearly, the monthly, or the permanent options. We have different types of licensing, UAV, medium format, full format imagery, and also satellite data based on your needs. We offer a node lock or floating license, and also you can download a free trial on our software on simactive.com. And for marketing purposes, we offer a free processing to show you what we can do with your own data sets with our team here at SimActive. This online training session. My name is Simon Grandin, and I'm the Photogrammetric workflow specialist here at SimActive. And thank you very much, and have a great rest of the day. Thank you. Bye-bye.